Hello students, this is grade 10 physics class, chapter 12, electricity. In last video class we have seen the factors affecting resistance of a conducting wire. Am I right? Yes. In this session we are going to start our next topic. What is that? Next topic. Yes. So in order to start next topic, we must recall what are the things we have seen in previous video class. Is it clear? Yes. In previous video class we have seen the factors affecting resistance of a conducting wire, isn't it? Yes. There are few factors affecting resistance of a conducting wire. So what are they, sir? You ask me. So what are they? First one, length of a conducting wire. What is that? Length of a conducting wire. That is first one. And second one, yes, area of cross section of a conducting wire. Generally we say that is thickness of a wire. Yes. Third one, what is that, sir? Third one, nature of a conductor. Okay, or nature of the material of the conductor. That is third one. Yes. Fourth one, that is temperature of the material, which means temperature of the conducting wire. So these all are the factors which is affecting the resistance of a conducting wire. Is it clear? Yes. In my previous video class, we have discussed the first two factors which is affecting the resistance of a conducting wire. Am I right? Yes. First one, length of a conductor we have completed, as well as second one, yes, this area of cross section of a conductor, which means the thickness of the conductor we have completed. Okay, yes. In previous video class, we have discussed about how does the length of a conductor affecting the resistance of a conductor. Then second one, how does the thickness of a conductor which is affecting the resistance of a conductor. Is it clear? Yes. The first two factors completed, isn't it? Yes. In this session we are going to start next two factors. Next two factors. How does the next two factors which is affecting the resistance of a conductor in conducting wire. Is it clear, students? Yes. First one, how does the length of a conductor which is affecting the resistance? Is affecting the resistance. For example, if you take two wires, okay, if you take two wires, first wire is a long wire and second wire is a short wire. In which wire will have a more resistance? Yes, obviously the long wire will have a more resistance. Is it clear? Yes. So if the length of a conducting wire is increases, corresponding the resistance of a conducting wire also increases. If the length of a conducting wire is decreases, corresponding resistance will decrease. Is it clear, students? It's a very easy one. So resistance is directly proportional to length of a conductor. Okay, resistance is directly proportional to length of a conductor. If length of a conductor increases, corresponding resistance also increases. If the length of a conductor decreases, corresponding resistance also decreases. Is that clear? Yes, that is the first one. I'll write this formula here. Okay, first of all I'll write the title, the factors affecting resistance. This is the main title. Yes. First formula, what is that, sir? That is R, so directly proportional to L. R directly proportional to L, which means resistance is directly proportional to length of a conducting wire. If the conducting wire length is increases, corresponding the resistance will increase. If the length of a conducting wire is decreases, corresponding the resistance will decrease. That is first one. So in this manner, the length of a conducting wire affects the resistance of a wire. Is it clear? Yes, very easy one. Okay, yes. So note this point. Long wire has more resistance, whereas short wire has less resistance. Keep this point in your mind. The first one completed, isn't it? Yes. Second one, what is that, sir? Second one, that is area of cross section of a conductor, or otherwise we can say generally that is the thickness of a conductor. Thickness of the conductor. Is it clear? Yes. Consider two wire. The first wire thickness is less and second wire thickness is more. In which wire resistance will be more? You tell me. In which wire resistance will be more? Obviously the less thickness wire. Am I right? Less thickness wire will have more resistance, whereas more thickness wire will have more thickness wire will have less resistance. Less resistance. Is it clear? So why, sir? Why? Because note this point. If the conducting wire thickness increases, there will be more amount of space to electrons flow. More amount of space to electrons flow. So if the conducting wire has more thickness, electron can easily flow from one part of the conductor to another part of the conductor. Obviously there will be less amount of resistance because there is more space to electrons flow, so resistance will be less. Whereas if you take the less thickness wire, there will be less amount of space to electrons flow, so obviously there will be more collision. This collision is called resistance, so resistance will increase. Is it clear, students? Very easy. So resistance is inversely proportional to area of cross section of a conducting wire. If area of cross section of a conducting wire increases, resistance will decrease. If the area of cross section of the conducting wire decreases, resistance will increase. That's all. That is second one. So already we have discussed clearly in previous video class. Am I right? Yes. So second formula, what is that, sir? Resistance inversely proportional to area of cross section. Area of cross section. Okay, generally we say thickness. So if the conducting wire thickness is more, resistance will be less. If the conducting wire thickness is less, resistance will be more. That's all. Okay, the two factors completed. First one, length completed. So resistance is directly proportional to L, that is completed. And second one, resistance is inversely proportional to area. So two factors completed, students. Am I right? Yes, two factors completed. So in previous video class we have discussed how does the length and thickness of the conducting wire affect the resistance. We have discussed it clearly. I hope that will be very clear for you. Am I right? Yes. Next we are going to start a third one. What is that? Yes, third one. So what is third one, sir? Third one, that is, what is that? Yes, a nature of a conductor. What is that? Nature of a conductor. Yes. So the third factor, this is both a formula. Yes, the third factor, what is that? Nature of a conductor. This is third one. Okay, third factor which is affecting the resistance of a conductor is nature of a conductor. What is that? Nature of a conductor. Is it clear? Yes, this is third one. Yes. Look at here. In this world, everything is made up of atoms and molecules. Am I right? In this world, everything is made up of atoms. For example, the table is made up of atom. This chair is made up of atom. The book, this mic, the mobile phone, this wall, this tube light, the fan, all things, everything in this world, in this universe made up of atoms. Atoms, am I right? Yes. Do you think this all atoms properties will be same? Already we know everything is made up of atoms and molecules, isn't it? Yes. Do you think the all things atoms property will be same? No, that's not possible. That is not possible, isn't it? Yes. This tube light is made up of atoms and molecules. This chair is made up of atoms and molecules. Okay, yes. But the tube light particles, note this point, the tube light particles properties differ from these table particles. Am I right or wrong? Yes. This mobile phone also made up of atoms. Yes, isn't it? Yes. Then this watch, this metal, this is made up of atoms or molecules. So this property of atoms made up of this mobile phone is differ from this watch atoms or molecules made up of. Am I right or wrong? Yes. So in this universe, everything is made up of atoms or molecules. These atoms or molecules differ from each other. The properties differ from each other. Am I right? Properties differ from each other. In similar way, note this point. In similar way, all conductors, note these points, all conductors also is made up of atoms or molecules, but these atoms or molecules properties differ from one conductor to another conductor. One conductor to another conductor. So which is this, based on these properties of a conductor, resistance will be changed. Resistance will be changed. Is it clear? Yes. For example, copper. Copper is one of the good conductor of electricity, whereas silver also is very good conductor of electricity. Do you think the both conductor resistance will be same? No, of course not. The both resistance never be same of resistance. Is it clear? Yes, it may be length may be same, diameter may be same, which means the area of cross section may be same, but resistance never be same. Okay, because the copper wire has some nature properties. Am I right? Yes. Whereas the silver wire also has some natural properties, the behavior, the arrangement of atom, the feature characteristics of atoms, and so many things. Okay. Yes. Look at here. Consider two conductor. Consider two conductor. First one is copper wire. This is copper wire. Another one conductor is there, that is silver wire. That is silver. Okay, yes. Both conductor length is same, that is 1 meter. Length 1 meter, yes, 1 meter length. Then here also 1 meter length, yes. As well as the both conducting wire thickness also same. Look at here, thickness also same. Yes, this is a 2 meter square. 2 meter square thickness, which means area. Here also the silver wire thickness also 2 meter square. Okay, so look at here. First consider the copper wire and another one silver wire. Okay, yes. The both conductors length is same, that is 1 meter. Okay, copper wire length also 1 meter, whereas silver wire length also 1 meter. Okay, yes. Then both wire, the area of cross section, which means generally we say the thickness also same. So the copper wire thickness is 2 meter square, whereas the silver wire thickness also 2 meter square. Okay, yes. Both the geometrical structures same. Both conductor geometrical structure is same, length same, as well as thickness is same. Isn't it? Yes. Next, I am going to ask a question. Do you think the both conductor resistance will be same? You tell me. Do you think the both conductor resistance will be same, but length same, both conductor length same, thickness same? But what about the resistance? Do you think it will be same for both conductor? Of course not. Of course not. The both conductor resistance will not be same, isn't it? Yes. Why? Because naturally the copper wire has some natural resistance, whereas the silver wire has some natural resistance. Okay, so even though the geometrical structure, which means the length and thickness same, resistance will not be same. What is that? Resistance will not be same. Okay, why? Because naturally the copper atoms or molecules properties differ from the silver. The atoms or molecules behavior, which means properties differ from the copper. Naturally, okay, each conductor has each properties, each resistance. That is the reason why the two conductors resistance will not be same. Two conductor resistance will not be same. Okay, yes. In a realistic, the copper wire resistance is more compared than the silver. Silver resistance less. Silver wire resistance less. Silver wire resistance less. Okay, naturally. Okay, we cannot do anything. Okay, yes. Look at here. Naturally, the silver wire resistance is less, whereas the copper wire resistance is more. Then you may ask me, then why we should not use the silver wire instead of copper wire, sir? Because if resistance less, current will flow easily. Current will flow much amount. Okay, yes. Then why we should not use silver wire, sir? Because silver is very costly material. Silver is costly material, that is the reason why we cannot use that. Whereas copper is cheaper material, that is why whatever the electrical appliances, there will be copper wire. Even in this room, there is circuit. The circuit wire is copper wire. The circuit wire is copper wire. The circuit wire is made up of copper wire because copper is a cheap material, cheap conductor, cheap metal. Okay, cost very very less. Whereas silver cost is very expensive. That is the reason why we cannot use all the times. Okay students, yes. So here naturally the silver resistance is less, whereas the copper resistance is more, but length, both the conductor length is same as well as thickness is same. So even though geometrical structure, which means length as well as thickness is same, the resistance will not be same. That is depend on nature. What is that? That is depend on nature of the conductor. Is it clear students? Yes. This silver also made up of atoms or molecules, copper also made up of atoms or molecules, but the behavior, the properties of the atoms or molecules differ from each other. That is a main reason. That is a main reason. The arrangement of atoms will be differ from each other, then the properties of atoms will be differ from each other, the characteristics of atoms and molecules differ from each other. So that is the reason why the two conductors resistance will not be same. That is depend on nature. Is it clear? That is depend on only the nature. Is it clear students? Very easy. Okay, for example, consider nichrome. Nichrome also one of the conductor. Nichrome also one of the conductor. Even though that is alloy, that is also under the category of conductor. Yes, this nichrome resistance is 60 times. The 60 times more than the copper wire. What is that? Note this point. The nichrome wire resistance is 60 times more than the copper wire. Okay, because naturally the nichrome wire has the more amount of resistance value, so we cannot do anything. Okay, yes. So naturally the nichrome wire resistance is 60 times more than the copper wire. Is it clear? Okay, but the length and diameter same, length and area same. Okay, for example, consider this is nichrome wire. This is nichrome wire. This is copper wire. So copper also one of the good conductor of electricity, as well as nichrome also conductor of electricity, not good amount, conductor of electricity. Okay, yes, this is copper wire, this is nichrome wire. This copper wire length is 1 meter, as well as the nichrome wire is length is 1 meter. Yes. Then copper wire, the area of cross section, which means thickness is 2 meter square, as well as the nichrome wire thickness is 2 meter square. The both conductor geometrical structure is same, length same as well as thickness is same. Okay. What about the resistance, sir? That is very good, very big question. What about the resistance, sir? Do you think the copper wire and nichrome wire resistance will be same? No, of course not. There is no possibilities, isn't it? Yes, because this nichrome wire has more resistance. Nichrome wire has more resistance, whereas this copper wire has less resistance. Look at here the nichrome wire resistance is 60 times more than the copper wire. 60 times more than the copper wire, not 1 time, 2 times, 60 times, a tremendous one. The 60 times more than the copper wire. So here automatically which wire will have more resistance? That is nichrome wire. Nichrome wire has more resistance compared than the copper wire. Both are conductor, both geometric structure is same, but resistivity is differ from each other. So resistivity depend on the nature of the conductor. What is that? Nature of the conductor. So naturally, note this point, naturally I have some different characteristics. You may have a different characteristics. Okay, so do you think the you and my character will be same? No, that's not possible. That's not possible. There is no way to get the both of us characteristics will be same. Okay, that is differ from each other. Okay, yes, that is depend on your generation. Am I right? Yes. Likewise, conductor also, each and every conductor also has different resistance value. That is naturally they have resistance value. Is it clear, students? Yes, that's all very easy. Okay, yes, so third one completed, that is the nature of the conductor. So what is the conclusion, sir? What is the conclusion? Naturally, note this point, naturally each and every resistance have, what is that? Natural resistance. Okay, natural resistance, that is constant value. We cannot change that. Okay, for example, so naturally the copper wire has some resistance value, whereas the silver wire has some resistance value. Naturally the zinc wire will have some resistance value, so whereas the aluminum wire will have some resistance value. Okay, so naturally all metals, which means all conductors have some natural resistance value. Naturally they have resistance value. Is that clear? Yes. For example, if you take 1 meter length of copper wire and 2 meter square area of cross section of a copper wire, whereas again if you take 1 meter length of a nichrome wire and thickness of the nichrome wire is 2 meter square. Okay, both the wire length same as well as thickness same, but resistance will not be same. Resistance will not be same. So here the both the conductor resistance depend on nature. Alright, both conductor resistance depend on only nature. Here the nichrome wire resistance is 60 times more than the copper wire. So obviously the nichrome wire has more resistance, whereas the copper wire have less resistance. Okay, so if you compare the copper wire with this silver wire, the silver wire has less resistance and copper wire has more resistance. That is nature. We cannot do anything. Okay students, yes. So what is the conclusion, sir? Naturally every conductor has, what is that? Yes, resistance. What is that? Resistance. That's all. Okay, it's very easy one. So this is third one, the third factor completed. Then what is fourth one, sir? You may ask me what is fourth one, sir? Fourth one, that is temperature. Fourth one, what is that? Yes, that is temperature. Fourth one, yes, temperature. Temperature of a conductor. So fourth one, what is that? Temperature of a conductor. This is the fourth factor which is affecting the resistance of a conductor. Resistance of a conductor. Is it clear? Yes, very easy one. Look at here. In this world, everything is made up of atoms and molecules. Likewise, the metals also made up of atoms or molecules. Is it clear? Yes. Okay, so when we increase, note this point. So when we increase a conductor temperature in a circuit, correspondingly, note this point, correspondingly the resistance will be increased. If we decrease the temperature of a conducting wire, what will happen? Correspondingly the resistance will decrease. Do you think that is possible? Of course that is possible. Okay, of course that is possible. Let's start with an example. Okay, yes, consider a copper wire or any other conductor. Any other conductor, it's not a copper wire, conductor. Just you consider conductor. Consider a conductor. It is a conductor. Connect the two ends of the conductors along with two terminals of the battery. Two terminals of the battery. Okay, yes. So many free electrons will be there. So many free electrons will be there. Yes. Okay, then apply the potential difference across the two ends of the conductor is 2 volt or 10 volt, whatever it is, no problem. 10 volt. Okay, note this point. Third one, what is that? Sorry, fourth one, what is that? Temperature of the conductor. So now we are going to see how does the temperature of the conductor affecting the resistance value in a circuit. Is it clear, students? Yes. Now look at here. Let's start with an example. Consider the conductor, copper wires, whatever it is. You just consider any of the conductor. Okay, just consider the conductor. In conductors, so many free electrons will be there. Is it clear? Yes. So connect the two ends of the conductors along with the two terminals of the battery. Two terminals of the battery, isn't it? Yes. Then apply the potential difference value. 10 volt or any other volt. Okay, I have applied 10 volt. Is it clear? Yes. Look at here. So consider this setup, this electric circuit is placed in room temperature. What is that? Room temperature. So it may be, consider this for an example, 30 degrees Celsius. 30 degrees Celsius, this is for an example. Okay, yes. First, this setup, this electric circuit setup is placed at 30 degrees Celsius temperature. 30 degrees Celsius temperature. Is it clear? Yes. Look at here. So when we apply the potential difference across the two ends of the conductor, what will happen? What will happen? Electron will start flow from one part of the conductor to another part of the conductor. Am I right or wrong? Yes. Electron will start flow from one part of the conductor to another part of the conductor. So when the electron starts moving from one part of the conductor, one part of the conductor to another part of the conductor, there will be collision. There will be collision, which means obstruction. That collision is called resistance. Already we know that collision is called resistance. Am I right or wrong? Yes. So this electric circuit setup is placed at 30 degrees Celsius temperature. 30 degree Celsius temperature, isn't it? Yes. So at 30 degrees Celsius temperature, so there will be some amount of resistance value in conductor. Am I right? There will be some amount of resistance value in conductor. Yes. So consider that resistance value is, it may be, you just consider 10 ohm. This is for an example. For an example, okay? Yes. That is, resistance value is 10 ohm. Is it clear, students? Look at here. Consider this set of electric circuit. This electric circuit is placed at 30 degrees Celsius temperature, which means room temperature. Is it clear? Yes. So when we apply the potential difference across the two terminals of the conductor, electrons will start flow from one part of the conductor to another part of the conductor. Am I right? Yes. When the electron starts flowing from one part to another part, there will be collision. Am I right or wrong? Yes, obviously there will be collision between the electrons and protons and electrons and other impurities, which means foreign atoms. Isn't it? Yes. So that collision is called resistance. Already we know clearly that collision is called resistance. Am I right? Yes. So when this setup is placed at the temperature of 30 degrees Celsius, so there will be some amount of resistance in the conductor, that is 10 ohm. That is 10 ohm. You just consider, you just imagine. This is for an example. Okay, students? Yes. Look at here. Next. This is first case completed. Yes. Next, I am going to place the same electric circuit setup at 60 degrees Celsius. What is that? 60 degrees Celsius temperature. Okay. First case 30. Second case 60 degrees Celsius. I am going to place the same electric circuit setup at 60 degrees Celsius temperature. What will happen? So this conductor temperature will be increased. Am I right or wrong? Yes. The conductor temperature increased, isn't it? When the conductor temperature increases, what will happen? The particles, which means electrons present in the conductor, observe the heat energy. Note this point. Observe the heat energy and will flow randomly here and there, very fast here and there. Note this point. When the temperature of the conductor increases, the electrons present in the conductor observe the heat energy, because temperature is a form of heat. Yes, isn't it? Yes. So these electrons observe the heat energy and move very fast here and there. Okay, move very fast here and there. So note this point. So when the electrons moves very fast from one end of the conductor to another of the conductor, there will be more amount of collision. Am I right or wrong? Yes, obviously there will be more amount of collision. This collision is called resistance. So obviously when the temperature of the conductors increases, correspondingly resistance also increases. Am I right? Resistance also increases. So in second case, the resistance may be 20 ohm. Resistance may be 20 ohm. That's all. That is a matter. Okay, yes. So note this point. So when the conductor temperature decreases, resistance value also decreases. When the conductor temperature increases, resistance value also increases. So this is how temperature affecting the resistance of a conductor. That's all. Resistance of a conductor. Is that clear? Very easy one. Please try to understand the concept. Okay, yes. So all pure metals resistance increases on rising the temperature. The all pure metal resistance decreases on decreasing the temperature value. Is it clear? It's very easy one. Very easy one. Okay, so temperature of the conductor is directly proportional to resistance. So temperature of the conductor. temperature of the conductor is directly proportional to resistance. So if the temperature of the conductor increases, corresponding the resistance value increases. This is for only the all pure metals, not for alloy, only for the pure metals. Yes, if the resistance of the metal, which means conductor, decreases, corresponding the resistance will decrease. That's all, students. That's all, very easy one. Okay, is that clear? Yes. Okay, so fourth one, what is that? Fourth one, the temperature of the conductor. Yes, in this session we will see how does the temperature of the conductor which is affecting the resistance value. Is it clear? Yes. First, consider the electric circuit is one of the conductor. First, place this electric circuit setup at 30 degrees Celsius temperature. What is that? 30 degrees Celsius temperature. Is it clear? Yes. Actually, there is a normal temperature, normal room temperature, isn't it? Yes. So when we apply the potential difference 10 volt, what will happen? The electrons will start flow from one part of the conductor to another part of the conductor. Yes. So when the electron starts flow from one part of the conductor to another part of the conductor, there will be collision. There will be collision. Am I right? Yes. Collision between the electrons and protons, as well as electrons and other impurities. This collision is called resistance. Okay. Yes. So at 30 degrees Celsius, the conductor resistance may be, note this point, may be 10 ohm. This is for an example, 10 ohm. Is it clear? Yes. Now come to the second one. Next, I am going to place this second setup at 60 degrees Celsius temperature. Where? At 60 degrees Celsius temperature. So obviously this conductor, this whole setup temperature will be 60 degrees Celsius. Am I right or wrong? Yes. Compare than first one, here the second case temperature is more. Am I right? Yes. So when the conductor, note these points, when the temperature increases, the electrons present in the conductor absorb the heat energy. Note this point, absorb the heat energy and will move very fast. From one part of the conductor to another part of the conductor. Because they are absorbing heat energy. Heat also one of the form of energy, because the temperature is increased at the rate of 60 degrees Celsius. Compare than first one, isn't it? Yes. So when the electrons moves very fast from one part to another part, there will be more amount of collision. Note this point, where there will be more amount of collision. So this collision is called resistance, already we know very well. So if the collision is more, then the resistance value will be more. Resistance value will be more. So in second case, the resistance of a conductor may be 20 ohm. 20 ohm. Yes. At note this point, at low temperature, the resistance of a conductor is less, whereas at high temperature, the resistance of a conducting wire is high. That's a very easy one. Okay, yes. So obviously we can write the temperature of the conductor is directly proportional to resistance. If the temperature of the conductor increases, corresponding resistance increases. If the temperature decreases, corresponding resistance decreases. That's all. Because if the temperature increases, there will be more amount of collision. That collision is called resistance, already we know very well. If the temperature decreases, there will be less amount of collision, because electrons move very slowly. Okay, there will be less amount of when the temperature is less. So when the temperature is less, there will be less amount of collision. So automatically there will be less amount of resistance. That's all. Very easy. Okay. Yes. Khatam. So 4 factors completed. The 4 factors completed, students. Am I right? Yes. I'll rub this. So 4 factors completed. So they all are affecting the resistance of a conductor. Okay, or otherwise we can say conducting wire. Okay, first one, length of a conductor, and second one, area of cross section of a conductor, which means thickness of a conductor, and third one, nature of the conductor, and fourth one, temperature of the conductor. Is it clear, students? Yes. Consider, look at here, this is first formula and this is second formula. First formula, what is that? R is directly proportional to L, and second one is R is inversely proportional to A. Okay, you leave it the remaining two factors, that is no need. Actually, that is okay, but with the help of these first 2 formulas, we are going to make a new formula. New formula. Is it clear? Yes. Look at here. What is the new formula, sir? What is that new formula, sir? Okay, look at here. So R is directly proportional to L. This is first one. Then R is inversely proportional to thickness of the conductor, which means area of cross section of the conductor. This is first formula, this is second formula. Is it clear, students? Yes, very easy one. Yes. Look at here. In both formulas, left hand sides are equal. Am I right? In both formulas, left hand sides are equal, so we have to equate right hand side. Am I right? Yes. So combining equation 1 and 2. Combining equation 1 and 2. Okay, if we combine equation 1 and 2, we can get R is directly proportional to length of a conductor and inversely proportional to area. Inversely proportional to area of the conductor. Is it clear? Yes, very easy one. Okay, look at here. According first one, what is that? First, the length of a conductor, R is directly proportional to L. Yes. Second one, R is inversely proportional to area. Okay, this is first formula, this is second formula. Yes. First equation, second equation, yes. So, in both equations, left hand sides are equal, that is R. So, we have to equate the right hand side. So, combining equation 1 and 2, we can get R is directly proportional to L and inversely proportional to A. Am I right or wrong? Yes. Look at here. So, there is directly proportional. That is directly proportional. So, in order to remove this directly proportional, so we need to put a proportionality constant. Am I right or wrong? Yes. Proportionality constant. Yes, that proportionality constant is rho L by A. This is very, very important formula, students. This is very, very, very important formula. Okay, look at here. R is directly proportional to L as well as inversely proportional to A. Inversely proportional to A. Is it clear? Yes. So, in order to remove this directly proportional, we need to put a constant. What is that? Constant. That constant is rho. That is proportionality constant. So, this is constant. Okay, what is that? That is proportionality constant. So, okay, this symbol name is rho. This symbol name is rho. R-H-O. What is that? R-H-O, rho. Okay, so in terms of physics, rho, which means that is resistivity of the conductor. Okay, actually it's a Greek letter. So this constant is called resistivity. This constant is called resistivity. The constant is called resistivity. So look at here, R is resistance, but rho is resistivity. Okay, you may ask me, so what is the difference between resistance and resistivity, sir? I'll explain later. Okay, students, you don't worry, I'll explain later clearly. Okay, yes. Look at here. R is directly proportional to L and inversely proportional to A. So, in order to remove this directly proportional, so we need to put a proportionality constant. What is that? Proportionality constant. That proportionality constant is rho. So, we can get R which is equal to rho into L by A. What is it? Rho into L by A. Yes. So, rho here, this is constant. That is proportionality constant. Okay. Rho is a proportionality constant here. Isn't it? Yes. That proportionality constant is resistivity of a conductor. What is that? The proportionality constant is called resistivity of the conductor. Is it clear? Yes. So, here, this letter, this is not a P. Okay. You don't write like a P. It's not a P. There will be some bending. This like, okay, you just bend the P, that will be resistivity, rho, that's all. So this is this letter is a rho, R-H-O. Okay, we can pronounce it, that is rho. Okay, yes. So actually it's a Greek letter. Rho is a Greek letter. So in terms of physics, the rho, which means resistivity of a conductor, What is that? Resistivity. Is it clear? Yes. What is resistivity? You may ask me, so what is resistivity, sir? I'll explain that question later. Is it clear, students? So very easy one. Okay, yes. So R, which is equal to rho into L divided by A. Okay, which means resistance of a conductor, which is equal to resistivity length divided by area of cross section, which means which means thickness. Is it clear? It's a very easy one. Okay, yes, I'll rub this side. So this equation is remaining. I'll write here. Okay, yes. Suppose if we need resistivity rho value, if we need the rho values, what will be there, sir? What will be there? So rho which is equal. So already with this same formula you write here. So R which is equal to rho L by A. Rho into L by A. So if you need this resistivity value, what will happen when this term, okay, L by A come this side, what will happen? It becomes reciprocal. Okay, yes. So we can get R into A by L which is equal to rho. So rho which is equal to R into A divided by L. R into A divided by L. Okay, yes. This is resistivity formula. To find out the resistivity, we can choose this formula. To find out the resistance, we can choose this formula. Okay, so we will see numericals one by one later. Is it clear, students? Yes, note this point. R is what is that? R is a resistance of a conductor. Rho is a resistivity of a conductor. L is a length of a conductor. And A is a thickness of the conductor. Okay, A is the thickness of the conductor. So note this point here. R which is depends on resistivity of the conductor, length of the conductor as well as area of the conductor, which means area of cross section, thickness of the conductor. Thickness of the conductor. Is it clear, students? Know these points. Very important point. So in a circuit, okay, in a circuit, the resistance of the conductor is density of the conductor, length of a conductor, and this thickness of the conductor. Thickness of the conductor is very important point. Note this point. Okay, here resistance depends on what is that? Yes, resistivity of, I'll write here, resistivity of the conductor. Okay, I'll explain what is resistivity later. Resistivity of the conductor, then length of the conductor, and third one, thickness of the conductor. What is that? Yes, thickness of the conductor. So very easy one. So resistance depends on the few factors. So in a conductor, there is resistivity of the conductor, length of a conductor, and thickness of the conductor. That's all. Is it clear, students? Yes. Next one, come to this one, resistivity. So here, if you want to calculate the resistivity value, rho which is equal to RA divided by L. RA divided by L. Yes, know this point. Sir, resistivity. What is resistivity, sir? You may ask me. What is resistivity and what is the difference between resistance and resistivity? That is very big question. So most of the students are getting doubt in this part. What is the difference between resistance and resistivity, sir? That is very big question. Okay, look at here. What is resistance, sir? First, you start with what is resistance. Resistance means nothing but the collision. Know this point? The collision, opposition to flow of electron, that is resistance. That is resistance value. I'm right. But resistivity means natural resistance of a conductor. Okay, natural resistance of a conductor. So naturally, know this point. Naturally, each and everything have resistivity. Okay, resistivity value. That is resistivity. Okay, so know this point. Naturally in this world, naturally all the things have resistance value. That natural resistance of a conductor is called resistivity. That is called resistivity. Is it clear? But note this point. When we apply the potential difference, there will be collision. That collision is called resistance. Whereas each and every things have natural resistance value. That is resistivity value. That is resistivity value. Okay, look at here. I'll explain clearly again. Listen here. First of all, I'll explain this. Then I'll come to what is resistivity. Okay, then you can get some idea. First one, what is that? First factor which is affecting the resistance. First one, length. Am I right? Yes. If the length of a resistance increases, resistance also corresponding increases. Am I right? Yes, so we can write resistance which is directly proportional to L. If L increases, which means length increases, resistance also increases. This is first equation. And second one, length is inversely proportional to thickness of the wire. If the thickness of the wire is increases, resistance will decrease. If the thickness of the wire is decreases, length will increase. So second one, R is inversely proportional to L. This is first equation, this is second equation. In both equations, left hand sides are equal, so we have to equate the right hand side. So combining equation 1 and 2, we can get R is directly proportional to L and inversely proportional to A. Inversely proportional to A, isn't it? Yes. So there is directly proportional. In order to remove this directly proportional, so we need to put a proportionality constant. Am I right? Yes. To change into equal. Okay. So we can get R which is equal to rho into L divided by A. Here what is rho, sir? You may ask me. So rho means nothing but that is proportionality constant. That is proportionality constant, that is rho. Yes, that rho is resistivity of a conductor. Note this point, a new term is involved here. New term is involved here, that is resistivity. You may ask me, so what is resistivity, sir? I'll explain later, wait a minute. So that rho is called resistivity of the conductor. So this symbol, actually this symbol is not a P, that is a, it will be like this. Okay, yes, this is rho. RHO, this pronunciation is rho. So in physics, rho, which means that is a resistivity of a conductor. So rho is a Greek letter. Rho is a Greek letter. Is it clear? Yes. Look at here. From this formula, so we can conclude resistance of a conductor is depend on resistivity of a conductor and length of a conductor as well as thickness of the conductor. As well as thickness of the conductor. Okay, so already we know nature of the conductor, the resistance of the conductor depends on nature also, then temperature also, okay, and otherwise resistivity, the resistance of conductor depends on resistivity, length of a conductor as well as area of the conductor. So from this formula we can conclude that. Is it clear? Yes. So look at here. So R which is equal to rho into L divided by A. Am I right? Yes. So if we need this rho value, which means resistivity value, what will happen? So when this term comes this side, it becomes reciprocal. Am I right? Reciprocal. So we can get R into A divided by L, which is equal to rho. So rho value is equal to RA divided by L, which means R into A divided by L. So resistivity which is equal to, what is that? The product of resistance of a conductor and area of cross section of a conductor divided by length of a conductor. You keep this formula forever. Okay, this is very, very important formula. Is it clear, students? Yes. So next question rising here. So what is resistivity, sir? I'll explain clearly. Look at here. I'll rub this side. You just pause the video and copy this all things. So what is resistivity, sir? So what is resistivity, sir? That is next question. Resistivity. What is resistivity, sir? Resistivity means nothing but in this world, everything's have some natural properties. Am I right or wrong? Yes. This table has some natural property. Then this mobile phone has some natural property. The light has some natural property. Whereas this fan also has some natural property. So in this world, everything have some natural property. What is that? Natural property. Yes. Similar things, know this point. See, similar thing, every conductor, know this point, very, very important. Every conductors have some resistance value. Naturally, they have resistance value. That natural resistance of a conductor is called, what is that? That is resistivity. Okay, I'll write the definition. Look at here. The natural resistance of the conductor is called resistivity. That is resistivity. Very easy one. That is resistivity. Okay, look at here. Consider copper wire. What is this? This is copper wire. Again, consider a silver wire. Silver wire. Second one, what is it? Yes, silver wire. And third, consider the nichrome wire. Nichrome wire. Okay, look at here. This copper wire. First, you consider three wires: copper wire, silver wire, nichrome wire. All these three wires length is same as well as thickness is same. Okay, so length 1 meter. Here also 1 meter. Here also length 1 meter. Thickness also same. Thickness also 1 meter square. Second one, silver wire also thickness. Silver wire thickness also 1 meter square. Even the nichrome wire thickness also 1 meter square. 1 meter square. Note this point, students. Consider three conducting wire. Not a conducting wire. You can choose anything. Okay, yes. Copper wire, silver wire, nichrome wire. Okay, all these three wires will have same. Note this point. All these three conducting wire length is same. 1 meter, 1 meter, 1 meter. Thickness also same. 1 meter square, 1 meter square, 1 meter square. Yes, is it clear? Yes. This copper also made up of atoms or molecules. This silver also made up of atoms or molecules. This nichrome also made up of atoms or molecules. Isn't it? Yes. Do you think these all conducting wire, the atoms property will be same? Property will be same? That is not possible. Do you think the all conducting wire, the arrangement of atom will be same? That is not possible. Okay, the copper atoms arrangement will be differ from silver as well as will differ from nichrome. The nichrome arrangement of atoms or molecules and behavior of the atoms or molecules differ from silver as well as copper. So note this point. So naturally the copper wire has some properties. Silver wire has some properties. The nichrome wire has some properties. Okay, so this natural arrangement of atoms, the properties, that is called natural resistance. That natural resistance is called resistivity, students. That's all. That natural resistance of a conductor is called resistivity. It's a very easy one. Is it clear? This natural resistance of a conductor is, what is the natural resistance of a conductor is called resistivity. Okay, very easy. You don't get confusion. Okay, yes. Then what is resistance, sir? Note this point. Then what is resistance, sir? Look at here. I'll draw here. Consider conductor. Consider the conductor, copper wire. What is this? This is copper wire. Okay, so many free electrons will be there. Okay, so apply the potential difference, 10 volt. Connect the copper wire. Copper is one of the good conductor of electricity. Connect the two ends of the copper wire along with the battery. Okay, and apply the 10 volt potential difference across the two ends of the copper wire. What will happen? Electrons will flow from one part of the conductor to another part of the conductor. So when the electrons starts moving, there will be collision. There will be collision between the electrons and protons, as well as electrons and other impurities. Yes. So this collision is called resistance. Resistance. Is it clear? Yes. Note this point. Here this resistance is happened due to this potential difference. Am I right or wrong? This resistance, this collision, generally we say that is collision. This collision is called resistance, already we know. These collisions between the electrons and protons and electrons and other impurity happen because of this potential difference. Am I right? Because of this potential difference. Is it clear? Yes. So due to potential difference, this resistance is happened, but here you are not connecting these all wires along with this battery. Okay, so even though we are not connecting these all wires along with battery, each and every wire has some natural resistance value. That natural resistance is called resistivity of the conductor. That is called resistivity of the conductor. Is that clear? Very easy one. Okay, yes. So I explain Tamil because it's very important term. You know, confused side. Okay, yes. நல்லா கவனிச்சுக்கோ. ரெசிஸ்டன்ஸுக்கும் ரெசிஸ்டிவிட்டிக்கும் என்ன சார் டிஃப்ரென்ஸு நீ கேட்கலாம். ரெசிஸ்டன்ஸுக்கும் ரெசிஸ்டிவிட்டிக்கும் என்ன சார் டிஃப்ரென்ஸ் அப்படின்னா, இந்த உலகத்தில் இந்த வேர்ல்டில் எல்லா திங்ஸுமே ஆட்டம்ஸால் ஆனது. ஓகே, அரேஞ்ச்மெண்ட் ஆஃப் ஆட்டம்ஸால் ஆனது. ஆமாவா? எஸ். அதே மாதிரி மெட்டல்ஸும் ஆட்டமால் தான் ஆயிருக்கு. ஆமாவா இல்லையா? எஸ். ஸோ இந்த எல்லா மெட்டலோடைய அந்த ஆட்டம்ஸோடைய அரேஞ்ச்மெண்ட் ஒரே மாதிரியாக இருக்குமா? கண்டிப்பாக இருக்காது, சான்ஸே இல்லை. சில ஆட்டத்தில் சில கண்டக்டரில் பார்த்தீங்கன்னா அதோடைய பேலன்சிங் பேண்டில் நிறைய எலக்ட்ரான்ஸ் இருக்கும், சில கண்டக்டர் பார்த்தீங்கன்னா கம்மியாக இருக்கும். ஆமாம், அதோடைய நேச்சுரல் நம்ம ஒன்றுமே பண்ண முடியாது, அதோடைய நேச்சுரல். ஆமாவா இல்லையா? எஸ். ஸோ இந்த அரேஞ்ச்மெண்ட் ஆஃப் ஆட்டம்லாம் இன்னும் ஒரு கண்டக்டர் வந்து இன்னொரு கண்டக்டர் கண்டிப்பாக டிஃப்ரெண்ட் ஆகிட்டே இருக்கும், கண்டிப்பாக டிஃப்ரெண்ட் ஆகிட்டே இருக்கும். எஸ். ஸோ இந்த அரேஞ்ச்மெண்ட் ஆஃப் ஆட்டம் டிஃபர் ஆகுது இல்லையா? ஸோ இதை தான் நம்ம என்ன சொல்கிறோம் அப்படின்னா, என்ன சொல்கிறோம்? ரெசிஸ்டிவிட்டின்னு சொல்கிறோம். இதை நம்ம என்ன சொல்கிறோம்? ரெசிஸ்டிவிட்டி சொல்கிறோம். ஸோ நேச்சுரலாகவே எல்லா திங்ஸுக்குமே திஸ் பாயிண்ட், எல்லா திங்ஸுமே, இந்த டேபிள் ஆகட்டும், சேர் ஆகட்டும், மெட்டல் ஆகட்டும், நான் மெட்டல்ஸ் ஆகட்டும், எல்லா திங்ஸுக்குமே இந்த ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது. எது ரெசிஸ்டன்ஸா? எலக்ட்ரிக் ரெசிஸ்டன்ஸ், அதாவது கரண்ட்டை ரெசிஸ்ட் பண்ணக்கூடிய வேல்யூ இருக்குது. ஸோ அந்த நேச்சுரலாக இருக்கிறதா நம்ம என்ன சொல்கிறோம் அப்படின்னா, என்ன சொல்கிறோம்? நம்ம ரெசிஸ்டிவிட்டின்னு சொல்கிறோம். தட் இஸ் ரெசிஸ்டிவிட்டி. பட் ரெசிஸ்டன்ஸ்னால் என்ன சார்? ரெசிஸ்டன்ஸ்னால் நம்ம ஒரு கண்டக்டரை நம்ம பேட்டரியோட கனெக்ட் பண்ணால் தான் ரெசிஸ்டன்ஸ் நடக்கும். நல்லா கவனிச்சுக்கோ. ஒரு கண்டக்டரை நம்ம பேட்டரியோட கனெக்ட் பண்ணால் தான் எலக்ட்ரான்ஸ் மூவ் ஆகும். எலக்ட்ரான்ஸ் மூவ் ஆகும்போது தான் அங்கே என்ன கொலிஷன்ஸ் நடக்கும். ஆமாவா? எஸ். ஸோ இது ரெசிஸ்டன்ஸ். ரெசிஸ்டன்ஸ்னால் என்ன? தி கொலிஷன் அப்போசிஷன் டு ஃப்ளோ ஆஃப் எலக்ட்ரான், தட் இஸ் ரெசிஸ்டன்ஸ். பட் நேச்சுரலாகவே அந்த கண்டக்டருக்கு, அதாவது இந்த கண்டக்டரை நீ பேட்டரியை கனெக்ட் பண்ணாமல் இருந்தாலும் அந்த கண்டக்டருக்கு ஒரு நேச்சுரல் ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது. அந்த நேச்சுரல் ரெசிஸ்டன்ஸ் வேல்யூ தான் ரெசிஸ்டிவிட்டி. அதுதான் என்னது? ரெசிஸ்டிவிட்டி. நீ பேட்டரியில் கனெக்ட் பண்ணாமல் இருந்தாலும், நோட் திஸ் பாயிண்ட், நீ இந்த எல்லா கண்டக்டரில் இந்த எல்லா ஒயரையும் பேட்டரியில் கனெக்ட் பண்ணாமல் இருந்தாலும் இதுக்கு இந்த ஒவ்வொரு கண்டக்டருக்குமே நேச்சுரலாகவே ஒரு ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது. ஓகேவா? அந்த நேச்சுரல் ரெசிஸ்டன்ஸ் வேல்யூ தான் என்னன்னா ரெசிஸ்டிவிட்டி. பட் ரெசிஸ்டன்ஸ்னால் எப்போ நடக்கும்? நம்ம ஒரு கண்டக்டரை பேட்டரியோட கனெக்ட் பண்ணி அங்கே எலக்ட்ரான்ஸ் மூவ் ஆகி அங்கே கொலிஷன் நடந்தால் தான் ரெசிஸ்டன்ஸ் வரும். ஓகே, அங்கே ரெசிஸ்டன்ஸ் வரும். பிகாஸ் தி கொலிஷன், தி அப்போசிஷன் டு ஃப்ளோ ஆஃப் எலக்ட்ரான்ஸ் இஸ் கால்ட் ரெசிஸ்டன்ஸ். பட் நேச்சுரலாகவே ஒவ்வொரு திங்ஸுக்குமே ஒரு ரெசிஸ்டன்ஸ் இருக்குது, ஒரு ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது. அந்த நேச்சுரல் ரெசிஸ்டன்ஸ் ஆஃப் அ கண்டக்டர் தான் என்ன சொல்கிறோம்? நம்ம ரெசிஸ்டிவிட்டின்னு சொல்கிறோம். ரெசிஸ்டிவிட்டி denoted by the letter rho. This is very 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 important point. Okay, natural resistance of the conductor. Is that clear, students? Okay, நீ பேட்டரியில் கனெக்ட் பண்ணாலும் இந்த ரெசிஸ்டிவிட்டி மாறாது. நல்லா கவனிச்சுக்கோ. இந்த பேட்டரியில் கனெக்ட் பண்ணாலும் ரெசிஸ்டிவிட்டி மாறாது. ஏன்னா அதுக்கு நேச்சுரலாகவே ஒரு ரெசிஸ்டன்ஸ் இருக்குது, அது எப்போவுமே மாறாது, அது எப்பவுமே வராது. ஓகேவா? பட் நீ கண்டக்டரை பேட்டரியில் கனெக்ட் பண்ணி பொட்டன்ஷியல் டிஃபரன்ஸ் இன்க்ரீஸ் பண்ண ரெசிஸ்டன்ஸ் மாறும், ரெசிஸ்டிவிட்டி மாறவே மாறாது. பிகாஸ் தட் இஸ் நேச்சுரலாகவே ஒரு கண்டக்டருக்கு ரெசிஸ்டிவிட்டி வேல்யூ இருக்குது. ஓகேவா? தட்ஸ் ஆல். ஓகேவா? ஸோ this is resistivity. The natural resistance of a conductor is called resistivity. That is called resistivity. Is it clear? It's very easy one. Don't get confusion. Okay, students, it's very easy. This resistivity, know this point? This resistivity never depend on the length, area and resistance. Know this point. What is resistivity? The natural resistance of a conductor, that is called resistivity. This natural resistance, which means resistivity, never depend on length, thickness and the what is that? Resistance value. Why, sir? Because that is natural. That is natural value. Okay, so natural values never change. Never change. You may ask me, sir, this is look at here. I'll rub this. I'll rub this. Know this point. Consider the copper wire. This copper wire length is 1 meter and thickness 1 meter square. 1 meter square. Okay, yes. So this copper wire will have some resistance value. Some resistance value, isn't it? Yes, some resistance value. Okay students, yes, consider that is 5 ohm. The resistance value is 5 ohm. Suppose if I decrease this length, what will happen, sir? If I decrease this length into 5 meter, so what about the resistance value, sir? Resistance value will decrease. Am I right or wrong? Yes, the resistance value will decrease because resistance is directly proportional to length. If length increases, resistance will increase. If length decreases, resistance automatically will decrease. It may be below the, okay, it will be below the 5 meters, so resistance will be 3 ohm. You just for an example, you just imagine that resistance will be 3 ohm. Yes, this is for resistance. Okay, sir. What about the resistivity, sir? What about the resistivity? Because here the wire length is changed. Actually, wire length is decreased. What about the resistivity, sir? Resistivity never change. Resistivity rho never change. Resistivity rho never change. On this point, never change. Why, sir? Because naturally each and every conductor has some natural resistance value, that is resistance value. So whatever the size, length, thickness, so whatever it is, resistivity never change. Resistivity never change. Suppose if the length is changed into 1 meter, how much? 1 meter, sir. Now the length is too small. So what about the resistance? Resistance value correspondingly will decrease. It may be 1 ohm. This is for an example, 1 ohm. But resistivity never change. Because, note this point, because the copper wire, before that the copper wire length was 10 meter, after that 5 meter, and it comes to 1 meter. Even though the copper wire length decreased, copper remains copper. Am I right or wrong? Yes, copper remains copper. Here, so when we change the copper wire length, the copper never change into silver, copper never change into gold, copper never change into aluminium. Copper remains copper. Am I right or wrong? Yes, copper remains. Here the copper remains copper. So the copper has some natural resistance, that is resistivity. That resistivity never change. Okay, so even though the conductor length may be changed, thickness may be changed, but resistivity never change. Here, even though the copper wire length is decreased from 10 to 5, again from 5 to 1 meter, copper remains copper. Am I right? Copper remains copper. So copper material has some natural resistance value. That natural resistance is called resistivity. That resistivity never change. Is it clear? For example, in this world, everyone has, what is that? Everyone has a natural voice. I have a natural voice. You have a natural voice. The principal sir has a natural voice. Okay, do you think all people voice will be same? That's not possible. The all people's voice never be same. I have a specific voice. You have a specific voice. Okay, look at here. If my size increased, okay, which means if I becomes fat, do you think my voice will change? No, my voice never change. Okay, if my height is decreased like this, do you think my voice will change? No, my voice will not change. If my height is increased like this, do you think my voice will change? No, my voice never change. Okay, my size may be increased or may be decreased. My height may be increased or decreased. My voice never change. Am I right or wrong? My voice never change. Here, my voice like a resistivity. My size may be changed, increase or decrease. My height may be increase or decrease. My voice never change. Because naturally I have own voice. That own voice never change whatever the size of my body, whatever the height of my body. That's all, students. Very easy. Is it clear? It's very, very easy. So, resistivity of a conductor never change. That is constant for each and every conductor. Okay, yes, the copper wire has some resistance value, silver wire has some resistance value, whereas the nickel, chromium, cadmium, alloy is like a tungsten, constant and manganese, all those things will have separate resistivity value, which is based on natural resistance value. That's all, students. Is it clear? Yes. So what is the conclusion, sir? What is the conclusion? So you may ask me, resistance means what is that? Resistance means nothing but, sorry, I rubbed that. Resistance means what is that? Yes. The collisions, when we apply the potential difference across the two ends of the conductor, the electrons will flow from one part to another part. So when the electrons move from one part to another part, there will be collision. There will be collision between the electrons and protons, and electrons and other impurities. This collision is called resistance. This collision is called resistance. Is it clear? Yes. So the collision opposition to flow of electron is called resistance. Whereas what is resistivity, sir? Resistivity means nothing but that is a natural resistance of a conductor. Naturally, each and every things have resistance value, some resistance value. That resistance value is called resistivity of a conductor. Resistivity of the conductor. Here the resistance is depend on what is that? Resistivity. So look at here, the resistance. This resistance is depend on resistivity of a conductor, length of a conductor, as well as the area of a conductor, which means thickness of the conductor. But the resistivity never depend on any things. Resistivity is never depend on any things. Is it clear, students? Yes. So resistivity never depend on any things. Resistivity depends on only one thing, that is, what is that? That is a temperature. That is only temperature. The resistivity will depend on only one thing, that is temperature. That is temperature. Is it clear, students? Very easy one. Don't get panic. Resistivity depends on only one thing, that is temperature. Okay. Yes. Then otherwise the resistivity never depend on length, then area of cross section, then resistance value. Is that clear? It's a very easy. You don't get confusion. Okay, students? Yes. So that is the difference between resistance and resistivity. Is it clear? Yes. That's a. Okay. Yes. So what is the resistivity value, sir? What is that resistivity value, sir? Okay, I'll give some important conductors resistivity value. I'll give some important conductor resistivity value. Okay. Yes. Okay. Yes. I'll give later. Note this point. So rho is the resistivity. Rho is the resistivity, which is equal to R into A divided by L. Am I right? Yes. So what is SI unit of resistivity, sir? SI unit. What is SI unit of resistivity? SI unit of resistivity. What is that, sir? You may ask me. Okay. Look at here. Rho is, what is that? Rho is resistivity. Am I right? Yes, students. So rho, which is resistivity. Okay. Yes. So what is R, which means resistance. What is resistance SI unit? That is ohm. That is ohm denoted by letter like this. Okay. Yes. If you want in a letter, I'll write the rho. Sorry, ohm. Okay. Yes. Then what is the SI unit of area? That is meter square and divided by, what is the area of this length? That is meter. Am I right? That is meter. So meter cancel. So there is another one meter. So resistivity SI unit is, what is ohm meter? Resistivity. Note this point. Resistivity SI unit. SI unit is ohm meter. Okay, or otherwise we can write in symbol form, that is, I'll write in symbol. First of all, I'll write in symbol. For that is ohm meter. This symbol is ohm and this is for meter. So we can write here ohm meter. So SI unit, note this point, very important. One more question. The SI unit of resistivity is ohm meter, because resistivity is equal to R into A divided by L. So what is rho? Rho is the resistivity is equal to R. SI unit of resistance is ohm into SI unit of area, which is meter square. Put meter square here, and divided by SI unit of length is meter. So meter cancel. So there is another one meter here. So SI unit of resistivity is equal to ohm meter. SI unit of resistivity ohm ohm meter. That's all, students. That's all very, very easy one. Okay, students? Yes. Note this point. I'll give some important conductor resistivity value. Resistivity value. Okay, yes. At 20 degrees Celsius temperature. Note this point. Very, very easy one. At 20 degrees Celsius temperature, the silver wire resistivity value is 1.60 into 10th power of minus 18 ohm meter. Silver, note this point, silver wire resistivity at 20 degrees Celsius temperature is 1.6 into 10th power of minus 8 ohm meter, whereas copper wire resistivity value at the temperature of 20 degrees Celsius is 1.69 into 10th power of minus 8 ohm meter, because SI unit of resistivity ohm meter. So that is the reason why there is ohm meter. Is it clear? Yes. Okay, sir. Conducting wire is okay. What is the length and what is the thickness? What is the length and thickness? Yes, this is for 1 meter length. This is for 1 meter length and 1 meter square thickness, which means area of the conductor. Okay, note this point. Look at here. Take 1 meter length of a conductor. This conductor is copper wire. Consider this copper wire. This copper wire length is 1 meter. And thickness is 1 meter square. Note this point. Consider copper wire. This copper wire length is 1 meter, whereas thickness is 1 meter square. Okay, so when the copper wire, length is 1 meter and the thickness is 1 meter square, then the resistivity of the copper wire will be 1.69 into 10th power of minus 8 meter. Ohm meter. Minus 8 ohm meter. Very easy. Very easy. So you may ask me, so if the thickness reduce, what will happen, sir? If the length decrease, what will happen? Whatever the thickness and length, resistivity never change. This is for an example. Okay, I have discussed. This is for an example. Okay, if you don't want, you no need that. You leave it. No problem at all. Okay, you just keep that in your mind. The silver natural resistance value, which means resistivity value is 1.60 into 10th power of minus 8 ohm meter, whereas the copper conductor resistivity value is 1.69 into 10th power of minus 8 ohm meter. Is it clear? Yes. This is for conductor. Copper, because copper is one of the good conductor, as well as silver is one of the good conductor. Okay, note this point. Compare than copper, silver resistivity value is less. Am I right? Silver resistivity value is less. Am I right? Then you may ask me, then why we cannot use that, sir, instead of copper wire in electric circuit? Because already I said that silver wire cost is very much. This is very expensive metal. Okay, we cannot use for all the times. But copper is cheaper material. Cost is very less. Okay, student, that is the reason most of the electrical appliances and circuit which is made by only the copper wire. Is it clear? Yes. So there is no need for you, the length and breadth, no need. You generally keep that in your mind, because you may get confusion. You generally keep that in your mind. The silver wire resistivity value is 1.60 into 10th power of minus 8 meter, whereas the copper wire resistivity value is 1.69 into 10th power minus 8 ohm meter. This resistivity value never change, whatever the size, which means the length of the conductor and thickness of the conductor, this resistivity value never change. That is constant for all the copper wire and all the silver wire. That's all. Whatever the wire length and thickness, this value never change. This resistivity value of silver never change. This resistivity value of copper never change. It may be 1 centimeter, 1 millimeter, or 2 meter, or 3 kilometer length of a wire, whatever it is, resistivity never change. Is it clear? Yes, Katam. Next one, insulator. For example, I'll give some important resistivity value for insulators. Insulator, for example, glass. The glass resistivity is too high. How much, sir? 10th power of 10 to 10th power of 14 ohm meter. Whereas the paper resistivity value is 10th power of 12 ohm meter. What is it meaning, sir? Actually, here in 10th power minus 8, which means here the 80 will be in front of this 160. Am I right? But here this 10th power plus 10, which means after this 10 there will be 10 zeros. After this here 10 to 14 zeros. That much of natural resistance has glass. That is the reason why they never allows the current. Current. Is it clear? Very easy one. Very easy one. Okay, shall I explain Tamil? Yes. நல்லா கவனிச்சுக்கோ. சில்வர் வந்து ரெசிஸ்டன்ஸ் வந்து ரொம்ப கம்மி தான், காப்பருக்கு ரொம்ப கம்மி தான். இதுக்கு என்ன சார் மீனிங்னா, இந்த 160க்கு முன்னாடி 80 இருக்கிறதா அர்த்தம். ஆமாம், இதுக்கு முன்னாடி 80 இருக்கிறதா அர்த்தம். அதே இங்கே பார்த்தீங்கன்னா இந்த 10க்கு அப்புறம் 10 0 இருக்கிறதா அர்த்தம். 10க்கு அப்புறம் 10 0 இருக்கு. ஸோ அந்த அளவுக்கு இதுக்கு ரெசிஸ்டன்ஸ் இருக்குது, நேச்சுரல் ரெசிஸ்டன்ஸ் இருக்கிறனால இது என்ன பண்ணுது, கரண்ட்டை அலோவ் பண்ணாது. ஸோ அதனால தான் இன்சுலேட்டர்ஸ் கரண்ட் அலோவ் பண்ணது. பிகாஸ் இன்சுலேட்டருடைய இந்த நேச்சுரல் ரெசிஸ்டிவிட்டி இருக்குல்ல, அதான் சரி நேச்சுரல் ரெசிஸ்டன்ஸ், அதாவது இந்த ரெசிஸ்டிவிட்டி வேல்யூ அது ரொம்ப அதிகமாக இருக்கிறனால தான் இன்சுலேட்டர்ஸ் என்ன பண்ணாது, கரண்ட்டை கண்டக்ட் பண்ணாது. அதே கண்டக்டர்ஸ் என்ன பண்ணும், அதோடைய ரெசிஸ்டிவிட்டி நேச்சுரல் ரெசிஸ்டன்ஸ் வேல்யூ விச் மீன்ஸ் ரெசிஸ்டிவிட்டி வேல்யூ வந்து ரொம்ப கம்மியாக இருக்கிறனால தான் அதை கரண்ட்டை கண்டக்ட் பண்ணும். இவ்வளோதான். That's all, students. Very easy one. Okay, very easy. Yes, I'll rub this. Yes. Okay, look at here. So rho already we know. So rho which is equal to RA divided by L. So what is A, sir? A which means area of cross section, or otherwise we can say that is thickness. Am I right? Yes. So consider your thickness is 1 meter square. You just consider that wire, that metal has 1 meter square thickness, isn't it? Yes. Then length, what is the length, sir? Length L, that is consider 1 meter. 1 meter. Yes. So look at here, rho resistivity is equal to R into A divided by L. You consider the length of a wire, sorry, the thickness of the wire. Consider this wire. This thickness of the wire is 1 meter square. The thickness of the wire is 1 meter square. Yes. The length of a wire is 1 meter. The length of a wire is 1 meter. Now what is the resistivity value, sir? You tell me. Now what is the resistivity value, sir? Look at here, resistivity. To find out the resistivity, we can choose this formula. Rho is equal to RA divided by L. Here, length of a conductor is 1 meter. Area, which means thickness of the conductor, is 1 meter square. Now find out the resistance value. You put the 1 and 1 here. Yes, look at here. So rho, which is equal to R into A value, how much? Yes, 1 meter square divided by what is that? Here, 1 meter. Because length is 1 meter. Yes. So meter cancel. 1 cancel. So here rho which is equal to R. Am I right or not? Both terms cancel. There is meter. That is not a meter. That is a unit. There is a meter. So no problem at all. Yes. But here rho which is equal to R. Yes. Note this point. Very important. If we take 1 meter length of a conductor, and that conductor thickness is 1 meter square, then the resistance of the conductor will be equal to resistivity of the conductor. It's very easy. Okay, so what is that, sir? You repeat again, sir. You may ask me. You repeat again, sir. Look at here. If we take 1 meter length of a conductor and the conductor thickness is 1 meter square, then the resistance of that conductor will be equal to natural resistance, which means resistivity of the conductor. Very easy, sir. Okay, look at here. So already we know each and everything has natural resistance. Natural resistance, am I right? Yes, the copper wire has natural resistance, a silver wire, aluminum, gold, all the things have natural resistance, am I right? Yes. So likewise, this copper wire, consider this copper wire, this copper wire also has a natural resistance value, that is 1.69 into 10th power of minus 8 ohm meter. Minus 8 ohm meter. Am I right or wrong, students? Yes, obviously that is right. Yes, if we take a copper wire of length 1 meter and its area of cross, which means thickness is 1 meter square, then the resistance of this copper wire will be equal to resistivity value, which means that will be equal to this value. Which value? This 1.69 into 10th power of minus 8 ohm meter value. So now come here. So already there is a meter and resistance value is ohm. So ohm meter. So here resistance of a conductor is equal to resistivity of a conductor. That is 1.69 into 10th power minus 8 ohm meter. That's all. Okay. Yes. Very, very, very easy. You don't get confusion. Okay. I'll explain Tamil because it's very important. Rho is equal to RA divided by L. இதுதான் ரெசிஸ்டிவிட்டி ஃபைண்ட் அவுட் பண்ணுறதுக்கான ஃபார்முலா. நமக்கு நல்லாவே தெரியும், ஒவ்வொரு கண்டக்டருக்குமே ஒவ்வொரு நேச்சுரல் ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது, அதுதான் ரெசிஸ்டிவிட்டி வேல்யூ ரோ. ஆமாவா? எஸ். அதே மாதிரி இந்த காப்பர் ஒயர் எடுத்துக்கோ, ஒரு காப்பர் ஒயர் எடுத்துக்கோ. இந்த காப்பர் ஒயருடைய லென்த் வந்து 1 மீட்ரு, காப்பரோட லென்த் 1 மீட்ரு, அதோடைய திக்னஸ் வந்து 1 மீட்டர் ஸ்கொயர். ஓகேவா? எஸ். ஸோ இந்த காப்பர் ஒயருக்குன்னு ஒரு ரெசிஸ்டிவிட்டி வேல்யூ இருக்கா இல்லையா? ஆமாம், காப்பர் ஒயருக்கு நல்லாவே நம்ம பார்த்தோம், காப்பர் ஒயருக்கு ஒரு நேச்சுரல் ரெசிஸ்டிவிட்டி வேல்யூ இருக்குது. அது என்னென்னா 1.69 10th power minus 8 ஓம் மீட்ரு. இது நேச்சுரலாகவே இருக்குது. எஸ், ஆமாம். ஸோ இந்த காப்பர் ஒயருடைய லென்த் 1 மீட்ரு, திக்னஸ் வந்து 1 மீட்டர் ஸ்கொயர். ஓகேவா? எஸ். ஸோ இந்த 1 மீட்டர் திக்னஸ், 1 மீட்டர் லென்த் உள்ள காப்பர் ஒயரு, சரி, 1 மீட்டர் லென்த் அண்ட் 1 மீட்டர் ஸ்கொயர் திக்னஸ் இருக்கக்கூடிய காப்பர் ஒயருடைய ரெசிஸ்டன்ஸ் வேல்யூ எதுக்கு ஈக்குவலாக இருக்கும் அப்படின்னா, அதோடைய நேச்சுரல் ரெசிஸ்டன்ஸ் இருக்கு இல்லையா, அதாவது ரெசிஸ்டிவிட்டி, அதுக்கு ஈக்குவலாக இருக்கும். புரியுதா ஸ்டூடெண்ட்ஸ்? நல்லா கன்ஃபியூஸ் ஆகிக்காத, ப்ளீஸ் கன்ஃபியூஸ் ஆகிக்காத. 1 மீட்டர் லென்த் உள்ள காப்பர் ஒயர் எடுத்துக்கோ, அந்த காப்பர் ஒயருடைய திக்னஸ் வந்து 1 மீட்டர் ஸ்கொயர்னு வச்சுக்கோ. ஸோ 1 மீட்டர் ஒயர் உள்ள காப்பர் ஒயருக்கு, சரி, 1 மீட்டர் அண்ட் 1 மீட்டர் ஸ்கொயர் திக்னஸ் இருக்கக்கூடிய காப்பர் ஒயருடைய ரெசிஸ்டன்ஸ் எதுக்கு ஈக்குவலாக இருக்கும்னா, அந்த காப்பர் ஒயருக்குன்னு ஒரு நேச்சுரல் ரெசிஸ்டன்ஸ் இருக்குல்ல, அதாவது ரெசிஸ்டிவிட்டி, அதுக்கு ஈக்குவலாக இருக்கும். இதுதான் ப்ரூஃப், அதுக்கு ஈக்குவலாக இருக்கும். ஓகேவா? ஸோ இவங்க காப்பர் ஒயரோட லென்த் வந்து 1 மீட்ரு, அந்த திக்னஸ் வந்து 1 மீட்டர் ஸ்கொயர். ஸோ இப்போ இருக்கும்போது இதுக்கு இந்த காப்பர் ஒயருக்கு ஒரு திக்னஸ் இருக்குமா? சரி, காப்பர் ஒயருக்கு ஒரு ரெசிஸ்டிவிட்டி இருக்குமா? நேச்சுரல் ரெசிஸ்டன்ஸ் இருக்குல்ல, அதுதான் 1.69 10th power minus 8 ஓம் மீட்ரு. ஸோ இந்த 1 மீட்டர் லென்த்து 1 மீட்டர் ஸ்கொயர் திக்னஸ் இருக்கும்போது இந்த காப்பர் ஒயரோடைய ரெசிஸ்டன்ஸ் இருக்குல்ல, ரெசிஸ்டன்ஸ் நம்ம பேட்டரியோட கனெக்ட் பண்ணும்போது ரெசிஸ்டன்ஸ் வரும்ல, அந்த ரெசிஸ்டன்ஸ் எதுக்கு ஈக்குவலாக இருக்கும்னா இந்த நேச்சுரல் ரெசிஸ்டிவிட்டிக்கு ஈக்குவலாக இருக்கும். இங்கே 1.69 10th power minus 8 ஓம் மீட்டருக்கு ஈக்குவலாக இருக்கும். தட்ஸ் ஆல் கான்செப்ட், வேறு எதுவுமே இல்லை, கன்ஃபியூஸே ஆகிக்கக்கூடாது. ஓகேவா? எஸ், these are all very, very important students. Okay, yes, I hope this class will be very useful for you. Okay, if you have any doubt, you watch this video again and again, definitely you will get some idea. ஓகே, நீ ஒரு டைம் பார்த்துட்டு புரியலைன்னா தயவு செய்து நினைக்காத, புரியலைன்னா ஒரு 2-3 டைம் பார்த்துக்கிட்டே இருந்தால் மட்டும்தான் புரியும். Okay students, yes, so this class getting over. I hope this class will be very useful for you. Okay, remaining classes I will see in next video class. Okay students, yes, thank you.